Okay, so let's go to the first couple examples. All of these you're going to solve. We're just going to start out simple. A simple radical equation. We're going to solve the equation and then practice checking our answer without showing work. But you can show work. First example, we're going to take the cubed root of x plus 2, set it equal to 0. Let's always check in these problems to make sure that this radical, anything that either symbolizes a radical, or let's say this was x to the 1/3 power, we want to isolate the radical on one side. Well, in order to isolate this, I have to get rid of anything that's hanging out outside of it, whether it's adding a number, subtracting a number, or if it's a coefficient. I would have to get rid of a coefficient too. The goal is to isolate this item. So yeah, subtract 2 on both sides. To undo a cubed root, we're going to have to cube both sides. These operations undo each other. I'm left with x equals -8. And let's check our answer. So if I plug in -8, cubed root of -8 becomes -2. When I add 2, it does become 0. We're going to practice checking our solutions so that way we definitely know we're right on the test on Friday. Next example. The goal is to isolate your radical. Isolate the root x. So I have to do that any way possible. So I'm going to get rid of this -5. And then I'll have to get rid of that coefficient. In front of this radical, I've got a -1. So I'll divide both sides by -1. It's the last step that, okay, now I have my radical isolated. I can undo that by squaring both sides. If I were to take, well, I'd have to take the square root of 1 first, giving me 1. Negative, since the negative is on the outside, -1 minus 5 is -6. It does check out. Do this one. 4th root of x equals 3. Two times x to the 1/2 equals 18. We need to recognize that x to the 1/2 is technically a square root. X to the 1/2 is technically a square root, so I'm going to have to isolate x to the 1/2. So if there's something in front of it or after it, I need to get rid of it. So I'm going to divide both sides by 2 first. And then wait a second, how do we undo a square root? To undo a square root, we square both sides. And let's recall, when you have a power raised to a power, you actually multiply powers. If you take a 1/2 times 2, you get 1. A 1/2 times 2 in your calculator gives you 1. So this is like x to the 1st power, which is what we want to end up with. X to the 1st power equals a number. And then I check it. 81 to the 1/2 power, well, that's like the square root of 81. 9 times 2 does get me 18. And now I have to undo this 3/2. I've got to recognize there's two things going on here. This 2 in a denominator means it's a square root. And this 3 means that's the power, x to the 3rd power. Let's talk about how we undo a square root. To undo this 3rd power, I'm going to have to take the 3rd root. It's going to be in the denominator. So the 3 now is going to be in the denominator. This strategy is whenever you raise the power as the reciprocal. Whenever you have a fraction as an exponent, we're going to raise both sides as the reciprocal to whatever radical we're looking at. Because what's 3/2 times 2/3? These cancel out, giving you 1. 3/2 times 2/3, it cancels to 1. So we have x to the first power equals 8 to the 2/3. Cubed root of 8 is 2, and squaring that number, we actually get an ending answer of 4. X to the 3/4 equals 1/8. Because my radical is by itself, I'm going to raise both sides to the reciprocal of this power. So this is like the cubed root of 1/8 raised to the 4th power. And last step is to take both of those, numerator and denominator, to the 4th power. So now we're just left with the radicand, 4 plus 3x equals 100, and you solve from there. So I recognize we take the cubed root, and on the left side, the radical goes away, but it's the right side. This 2 also needs to be cubed. So notice how 2 is also being cubed. So this becomes 8 times, well, this cubed root undoes with the 3rd power. So we're left with 8x. Use this example during homework. When you get stuck during homework, check to make sure, wait, did you raise everything to the power that you said it was supposed to be raised to?